If you had a shop and you wanted to set up a webcam in that shop and you wanted to get an email anytime a new customer enters the shop, how can you do it? The answer is you can use Python. That's what we're going to do in these videos. We will build a program which starts the computer webcam and it waits for objects to enter the view. And if a new object enters the view, the program will send you an email, and in that email, the object that entered the view is attached as a picture, as an image, just as you can see. So that's basically the program we want to build. We want Python to start the computer webcam, and the webcam should be live all the time and it should wait for new objects or persons. So whenever a new object enters the view of the camera captures that object, draws a rectangle around the object, and it triggers an email. So an email will be sent to your email address in real time, and that email will contain attached the image which contains the object which was moving at that time. Right, so this is quite a fun project, but it's also very useful. This is where you learn the skill of threading in Python. This is very important. Unlike you learn threading with a real world example like this one, you will have a hard time to understand what threading really is. So please stay tuned and let's move on to the next videos. See you. Welcome to today's programming concept. In this video you'll learn what images are from a computer science perspective. Please don't skip this video because in the second half of the video we're also going to look at some Python code. So what are images from a computer science perspective? That's something that as a programmer you need to know, because whenever you process images you need an understanding of what they actually are. In fact, today and tomorrow we're going to process videos and images. So let's look at images from a theoretical perspective first. Let's consider a very small image which has only 12 pixels, so 4 horizontally and 3 vertically. As you know, each pixel has a color, right? So for example, we have this blue color here, white pixels, white, purple, etc. Now, the computer stores this image as numbers. So this is a matrix which symbolizes this image, and I'll explain you now what these numbers mean. So each set of numbers represents a pixel. For example, the very first set of numbers 255, 0 and 0 make up the first pixel of the image. The second set of numbers make up the second pixel of the image, the third one make up the third pixel, and so on. Let's look at the fourth pixel. Let's zoom in here. What are these numbers exactly? Well, 187 is the amount of blue, 41 is the amount of green, and 160 is the amount of red. The combination of these amounts of blue, green and red makes up the purple color. You can see this, you can look at a graphic design software. If you do this combination, you're going to end up with this purple color. Now let's go back to the blue color. So the first number is always the blue channel. So that's 255 for blue, and that's the maximum number. You can have the maximum amount of the color. So it ranges from 0 to 255. Now 25500 means that this pixel has 255 units of blue and 0 units of green and 0 units of red. That's why this is pure blue. It only has blue. And then if you look at white, white is always a combination of full blue, green and red. Then we have one more white pixel here, and then we have the purple. So this first matrix here represents the first row of pixels. And then we have the next pixel, this here, the next one, and so on. So if you look at the last pixel here, this would represent the last pixel, which is white. The one before that is this greenish color here. So 47 of blue, 255 of green, so it's very green. And we also have some red. So this is some sort of yellowish green. Now here is where the video gets more interesting. Let's jump into PyCharm. I've created a project here and I've uploaded an image.png file. You can find this attached in the lecture resources. So this image is the one I was showing to you just earlier. So we have this blue and purple and black and green. So this also has 4 pixels horizontally and 3 vertically. So it's a very, very small image. It's just 4 kilobytes. Now, in Python, you can write a script by using the OpenCV library, which you can install with pip install opencv-python. Or you can install it from the Python packages. So please make sure that you're using OpenCV Python Node CV2. So you install it like this, but the way to import it is this here. So OpenCV is a Python library that does image processing. It can capture video from the webcam, it can process images such as making them grayscale, blurring them, etc. So it works on the pixels of an image or the pixels of a video. A video is also made of images actually, and you'll understand that better in the next videos. So this OpenCV library has this imRead method, which stands for image read. So it gets an image as input. This image should be in the project directory here, so image.png, the one I just showed you. Then you can print out that image using print array. Let me comment this out first. Let's print the image and see what we've got. So that's the same numbers, the same matrices that I was just showing you earlier in the presentation, in this video. So as you can see, for example, that's 255 of blue, 0 for green and 0 for red. So that was the very first pixel, the blue one. And then we have all the other pixels one by one, just as I showed you earlier. So what is this array anyway? Well, you can print out its type, run again. You'll see that this is a NumPy array. And NumPy is also a Python library. It's a third-party library, but OpenCV installs it when you install OpenCV. So it's a dependency of OpenCV. NumPy has this array, which you just saw. So that is the main object of NumPy. So it looks like this. It's like a list of lists. So it's used to store numbers and numbers and numbers. So big amount of numbers, because images have many pixels. This image here has only 12 pixels, but normally a real photo or picture you'll have something like 1000 by 1000 pixels, which is 1 million pixels, right? So in such an image, 1000 by 1000, you have 1 million pixels and times 3 for each of the color channels. You'd have 3 million numbers, right? So 3 million of these numbers. And then when you have a video is made of images, so you usually have 30 images per second. So that's a lot of data, a lot of numbers. But NumPy is a very efficient library, so it doesn't slow things down. And so OpenCV is built on top of NumPy. And with OpenCV, you can display actually the images. And if I uncomment this other print function, if I run this, that shape property of the array, which we create in here, should display the dimensions of the array. So it's 3 by 4 by 3. What does it mean? 3 is the amount of pixels vertically. So we have these amounts of pixels vertically. We have 4 pixels horizontally. And then we have 3 channels, right? So blue, green, and red. So OpenCV works on this order: blue, green, red. There are other programs which may have RGB and not BGR, but OpenCV uses BGR. And just before we close the video, I want to also show you this other script, which is basically the opposite of the one I was just showing you. What this does is that we import NumPy here, right? We import OpenCV, and then we create a NumPy array manually. So A is the variable which will contain this array. You see, this array is a method. It opens in here and it closes in here, and inside it contains a list of lists. So that's basically that array that I was just showing you. Here it's the same array, but we're doing the process from the other way around. So we get a NumPy array, we get numbers, and then we produce an image. So if I run the script, this script will get that array and it will execute the imWrite method. We give a name to the image that will be saved in the directory here, and then we provide the array that will be written in that image. So this array will be converted into a PNG image. So if I run this, it will create this image.png file, which is again 4 horizontally, 3 vertically. So that's how you read, that's how you create images. And let's move on with the next videos. See you. Hi, welcome back. In this video we will start coding our email webcam detection app. I demonstrated you the app in the previous video, so let's begin. Create a PyCharm project, and we will basically need 2 Python files here. Why we need 2? Let's call this emailing and main. Please don't name it email because that may clash with a Python library called email. So use another name. We need 2 Python files because think about the program we want to build. It has 2 parts. It has the webcam part and it has the emailing part. So the webcam is the front end part and the emailing part is the backend. Therefore, in main.py, I will write the script which starts the computer webcam. That script in main.py will also detect movement in the webcam and it will capture that as an image. Then this main.py script will tell the emailing script to send an email using that image as an attachment in the email. And that's all. So let's begin with the front end. the first thing I want to show you how to do is how to start the webcam of your computer. So for this, obviously you need a webcam in your laptop or desktop computer. So you either use the integrated computer of your laptop or use another USB camera or something similar. There are also apps which connect your mobile camera to be used by your computer. So you'll have to do some research on the internet if that's the case, if you don't have a camera on your computer. Right, so considering you have a webcam, then what you want to do is import CV2. CV2 is actually called OpenCV, so you shouldn't be installing that using this button, but go to the terminal instead and make sure that venv is activated and do pip install opencv-python. So opencv-python. That will install OpenCV for you, and you import it with CV2. Then we want to start the video. To start a video from the webcam, using the webcam, you write a variable and you say video is equal to cv2.video capture. So this class. And inside the parentheses, you have to place a number, either 0 or 1 or 2. So if you have only one camera in your computer, which could be the case if you have a laptop, for example, you have the integrated camera, then you should place 0 to use that main camera. But if you want to use your secondary camera, you should use 1. So perhaps you have a USB camera attached to your laptop and you want to use that USB camera, please use 1 here. Otherwise, use 0 to use the main camera. You can try either way and see what works for you. And then write two variables, check and frame, equal to video. Video is this variable, dot read in parentheses. So that's a method. And then for now, let's print check and let's print the frame and see what these will be. Run. And if you notice it, what happened is that my computer camera, my webcam lights turned on, so the camera started and then it turned off. And I got true as part of the check variable and this matrix as part of the frame variable. So this is a matrix, it's a NumPy matrix. So CV2 collaborates with a NumPy library. The NumPy library provides these matrices as its specialized object type. So we have lists, which come directly from Python, and we have matrices, which come from NumPy. So basically these are list of lists. And this thing here, which happens to be zeros, I'll explain you why. This thing here is representing the frame, the image that the camera captured. So it's only one image actually. So the frame is the image and the image is represented as numbers. Why is it 0? Well, because my camera didn't have time to actually do something. So if you import time here and then you say after this video capture, after video read, because this simply sets up the camera and this actually reads the first frame of the video. Because a video, what is a video? A video is just a series of images. When you hear, for example, 30 frames per second, that means the video has 30 frames per second, and these video players, what they are doing is they are simply displaying these 30 images in 1 second, and you see it, you perceive that as a video. So time.sleep 1 second here, and then I'll get another check 2 frame 2, so that was check 1 frame 1, we sleep for 1 second, another sleep here, sleep for another second, and a third check 3 and frame 3 here. And then let's print out frame 3, for example. Execute. Now the camera should be staying on a bit longer. And so what I've got here is the third frame. Right? Now we have some numbers here. All these rows represent one single pixel in the image. And each of the values represent the blue, the amount of blue, the amount of green, and the amount of red. So the combination of these 3 basic colors will construct the color for that pixel. And then we have the other pixel again, BGR, so blue, green, red. The same for the other pixel, and so on. So that constructs an entire image, an entire matrix, whatever you like to call it. So this is quite long, but you see these dots means these will continue. There will be many pixels, but they are simply not displayed here in the command line because it's too many data, too many pixels. Right, so you are wondering, right, we have the frames as numbers, but how do we see the frames? Can you show the frames on the screen? Yeah, you can do that using the IMShow method, but IMShow should be used inside a while loop. So let's create a while true loop, and video capture should be outside of the while loop, but reading the frames should be inside the while loop. So previously we were applying the read method multiple times, but now since we are using a while loop, that means we don't need to manually add the read method multiple times. The while loop will execute read multiple times, and I'd like to remove this once from the variable names. So basically in each iteration we will have a frame. So that will happen very fast. And then you say cv2.imShow, you give a name to this, let's say my video, and then provide the frame variable. This contains those matrices, so the images. So you want to display the images every fraction of a second or so. Remove this frame 3 as well. It's a good idea that before you get the first frame, you use time.sleep for 1 second perhaps, because that will avoid these black frames. So you give the camera some time to load. Then you want to create a key variable which should be equal to cv2.wait key 1. So cv2.wait key 1 as argument, and then you say if key is equal to ort q. I'll explain you what this is. For now, please follow me here as I'm typing. Break, and then go outside of the while loop. So in this level of indentation, and you say video.release. So you point to that video variable and you release the video. Let's see now how this will work. So let's execute. Once you run the script, this should pop up a program. So check among your programs, you should see something with this icon, this Python rocket. So open that and you should see yourself there. Now the video is a bit slow, and that is because in the script, I place the time.sleep method in here. So that means every loop will be 1 second apart from each other. That means the frames are being shown with a lag of 1 second, basically. So in other words, we are creating 1 frame per second here, if you use that. And of course, if you print out the frame here somewhere inside the loop, wherever you like print frame, that variable, you'll see that the numpy array, the matrix will be printed out every 1 second here. So to fix this, you want to place that time sleep outside the loop. So once you start the camera, you wait 1 second and then you capture the frames. So you wait 1 second for the camera to load. Then stop the script, run again, and look for that program again. So there it is. So now the video is smooth and we can go back to the script and I'll explain you what this does. So these lines, well, this creates a keyboard key object basically. And then you say that if the user presses the Q key, we will break the video. So let's try this. Go to the view, focus with your cursor, make sure the focus is in the app and not in another app on your computer, and press Q. That will stop the program. So it will release the video and yeah, the camera stops. And now if you want to process those frames, you should do stuff in here. You should code lots of things in here if you want to save them and so on. That is something we're going to do in the next videos. So for now, that was how to start the computer webcam. Thanks for following and I'll see you later. Hey, welcome back. Our program is working fine. It can detect objects and draw a rectangle around them. Now it's time to think about how we can connect this script with an email sending function. Well, for that, we're going to write a function in a separate file. So in this emailing.py file, for example. So let's define a send email function. And we're going to write the code later on. So for now, let's just print something like email was sent. Right, so this function now will have to be called from main.py. So when and where are we going to call the function? At what point in the script? So think again about this. The frame is static, no objects have entered the view, and then an object enters, right? So when this happens, we draw a rectangle around the object, but this should also be the point when we trigger that email sending function. So when we detect that there is movement, and that is, in my script, that would be in line 26, right here. Well, actually, it's not exactly line 26, but it is line 28. Because in here we are saying that if the contour is less than 5,000, the area, then we assume that there is no object, there's no real object in the camera. So in fact, if that doesn't occur, then this occurs. So at this point, we know that there was an object, so in line 28. But we can also do this like, you know, we can assign a rectangle variable to cv2.rectangle. So we store the rectangle arrays, the rectangle numpy matrices in this variable, and then we say if rectangle send email. Send email should be imported. So from emailing import send email. So make sure that this is the name of your function, send email from emailing.py, send email from emailing. So we call that function in here if we notice a rectangle. Notice that if rectangle is inside the for loop, so one indentation level below the for loop. So let's try this. Run. So I always start with a static frame, so please don't show on camera when you are just running your program. And then introduce an object there. For example, I just introduced an object and we got an error. It says that the truth value of an array, so rectangle is an array, with more than one element is ambiguous. So you should use .any or .all. So that's what we do here. Rectangle.any, as we are being advised from the error messages. Run again. That's a static view. Let's introduce an object. So there we go. And you can see that in the terminal we have this email was sent string being printed out multiple times. Right? So the email function, it's being executed as many times as there are rectangles being detected. So this would mean that the email function would be executed multiple times, and that means the email would be sent out multiple times, but that is not what we want because that's just too much. So we only want to send the email once. Now there might be different ways to approach this, but one way which we will use is to send the email when the object has exited the frame. So which means that now there's no object and then an object enters the frame. We don't send the email yet, but then when the object has exited the frame, then is when we send the email. So let's see how we can do that. Well, to do that, we can assign a value of 1 to this status variable. So this variable is 1 when there are rectangles. In other words, when there is an object in the view. Otherwise, status will be 0. Status is equal to 0. So when the loop starts, we always reset the status value. So basically we reassign 0 to status, but then if there are objects, the status variable is updated to 1, right? Then we also have, outside of the loop, we have a status list, which is equal to an empty list for now. So status list is equal to an empty list, and then we go in here where we are sending the email, and we go at this level, in the same level with the while loop, so indented under the while loop, but at the same level with the for loop, and we say status list.append. I know you are lost, but I'll explain this to you, what I'm doing here. So status list.append status. Why am I doing this? Well, let me print out status list so you see what's going on here. And I'll run the program. So make sure that these two are one indentation level. You see, inside the while loop. So run the script. And what we're getting is the status. If I introduce now this object and then I quit this, if you scroll to the end of this, you're going to see that the latest statuses are ones. So the latest values are ones. And in here, this is where the object entered the view, right? So we switched from a value of 0 to a value of 1. Let's do this again. Let's try again. So we have zeros, an object entered, it exits the frame, quit. Again, here is the switch from 0 to 1, the object entered the frame, but then in here, 1 to 0, this is where the object exited the frame. Now we can modify this status list by saying that status list is equal to status list -2 up to the end. So what this will do is basically, let's suppose we have this amount of items in a list. So status list is equal to this list, right? Zeros and ones. So what we're doing here is basically this. So let me copy that in here. And now status list is going to be updated by containing only the last 2 items of the list, because that's what we're interested about. We're only interested about the last 2 items if they are changing or not. Because if then status list 0, which is the first item, if that is equal to 1 and status list 1, so this item is equal to 0, that means the object has just exited the frame, right? Because this was 1, which means that there was an object currently in the frame, but then that changed to 0, right? Oh, sorry, this is equal to 0. So that changed to 0, and that means the object has just exited the frame. In that case, we might want to send out the email. So I'll cut that send email call from there and paste it in here. And let's run the script. Right, so now we get only these 0, 0, 0, 0. Let's introduce now an object. We have ones. No email is being sent out just yet. Now when the object disappears, you saw that we got this printed out, this email sent. Yeah, email was sent. So this happened at the time when we switched from 1, 1 to 1, 0. At this point is when we sent out the email. And the email should also contain one of the images which will show the object inside the frame, the view, like a screenshot of the video with the object inside the frame. And that's something that we'll do in the next videos. So with this, we are done, and I'll see you in the next one. See you. Today you worked on processing frames of videos with OpenCV. Now your task for today's exercise is to create this web app. I'll show you some code to get you started though, because this contains something that we haven't covered yet. So in this video, I'll cover that aspect as well. But first, let's demonstrate the app, how it works. So if the user presses the start camera, then the user shows up. And so the idea is that your task is to create this app, but also to add this date, the day actually of the week, and the current time, which is still ticking. So sort of timed video camera. Right, so let me go to PyCharm, and I want to show you a simple version first. So this is not the solution is a bit more complex. This code here, what it does is this. Let me execute it. Streamlit run. So we're using Streamlit here. And this script is named simple.py. So run simple.py. This app is a bit simpler than the one I just showed you because when the user starts the camera, the video shows up, but this time in here you see it's hello, it's not the date. So this is a bit simpler. So this app is constructed by this code. So we've got this motion detected title and start camera button. And so if the user presses that start button, that means the start button has a value. So if start, if the button has been pressed, then we prepare an image with Streamlit. So st.image with this list as input. So this will be like a placeholder where you inject the frames of the video. Then you start OpenCV. So previously in the course, we did cover a simple app with Streamlit. So Streamlit can also do this the other way without using OpenCV. But when you use OpenCV, you have more control over the frames. So you're working on a lower level code. So you have more possibilities what you can do with your code, as we do in this example where we will write some text in the image, and you can also write dates and times, which is your task for the day. So if the user presses the start button, then we construct the while loop, as you know. So we read the frame from this. You can call this camera or video, whatever you like. Then the frame is converted to color BGR to RGB. I wanted to show you this technique as well. You don't have to use it, but if you ever want to convert the channels from BGR, which is the standard of OpenCV, and you want to have the frames in RGB instead, then you can use this code. So every frame will be updated to the current frame, but with RGB. So that means then if you give some colors, for example, we give the color of text here, that means 20 is for R, so for red, and 100 is for green, and 200 would be the amount of blue. So this is optional, but just be aware that if you change that, you should supply the numbers in the correct order in RGB. So that is the code that writes text in frame. It has these arguments. I think these are self-explanatory. So that's the frame and that's the text you want to write. That's the coordinates of the image. They start from the upper left corner of the image. So if you're saying 50 here, that means we are 50 here. So from the left border to the text, and the other 50 is from the upper border up to the text where it begins. That's the idea here. Then we have the font and we have the font scale, how big you want the font to be. You can experiment with numbers. That's the color of the text, that's the thickness of the text, and that's the line type used to draw the text by OpenCV. And then inside this while loop we write the frame. So your task now is that instead of showing hello, you should show that dynamic day and the current time, just as I showed you in the first demonstration in this video. So thanks and see you later. Hi, in this video I'll show you the solution to the Streamlit app, which constructs this camera view, and we also have this Wednesday and the real time here. So let me show you the complete code. So that's the complete code, that's the first line, and that's the last line of the script. Let me explain you how I did it. I'll simply explain you the lines I added in addition to the lines that I showed you in the previous video where I gave you the task for this project. So these are the lines I added as new, and also line 3. So in line 3 I imported datetime, so the datetime class from the datetime library, because datetime, the class, allows me here in line 17, it allows me to get the current time. But this will be a datetime object, so it's a special object. It's not meant to be written as text. That's why in here I get that datetime object, which is stored in the now variable. So this variable here is also here. So I get that variable, that object, and I extract the string, a string from that object. So basically converting that. But in the string, we only show the name of the day. So the day of the week, for example, Wednesday. And I placed it at these coordinates. So 3080 means 30 from the left and 80 from the upper border. So the rest, I suppose, is self-explanatory since we covered this in the previous video. So I did this 2 times. I used the put text method 2 times. One for the day, Wednesday for example, and another to show the time in hour, minutes and seconds. So this one is in another color, and that was white, this is red. So that's it, basically. That's my implementation of this app. Thank you for following, and I'll see you later.